Hi everyone, welcome to another video lecture of Advanced Computer Programming. In programming, there may occur events during the execution of your program which may disrupt the normal flow. For example, when you divide a number by 0, or you're trying to access an array index which is out of bounds. Such events are called exceptions. And if they are not handled, the program stops execution and crashes. Before we get started, let's have a look at what we will be covering in this lecture.
In this part, we will be introducing exceptions. We'll have a look at some fundamentals for handling the exceptions, and we'll talk about what happens if we do not catch the exceptions. And finally, we will have a look at different types of exceptions and discuss the exception class hierarchy.
This lecture will be focusing on the theory, whereas you can also watch the hands-on programming tutorials in a separate video. So, first of all, what is an exception?
An exception is actually a runtime error, and the runtime error may occur because of multiple reasons. For example, you are pointing to an object whereas your reference through which you're pointing is null, or you're dividing a number by 0, or for example you're accessing an array with an invalid index which is not actually existing inside the array, which actually causes an array index out of bound exception. So there are various types of exceptions that are already provided and defined by Java, which we will see later in this lecture, whereas we just want to explain right now that what is an exception. So what happens whenever that runtime error occurs, an object is created by Java which contains all the required information. For example, the type of the exception, the location at which that exception occurred, the name of the file, and a particular message which explains or describes that exception. We will also cover that later. So actually, whenever that condition arises, the exception is created and it is thrown in the particular method from where the error was actually caused. In response to that particular method has two choices. Choice number one is to handle the exception itself, and choice number two is to pass that exception on. So where that exception will be passed on, it can be passed on from where that particular method is actually called, from where the current method is actually called. So we just pass it on, and again the same scenario repeats. That method will have two options, and the option number one is to handle the exception itself, and option number two is to pass it on. So in the same fashion, either at some point the exception is actually caught and handled and processed, or it is kept on passing on and on until it reaches to the runtime environment and it is passed on to the operating system, which causes your program to crash. So there are two possibilities of creating and throwing the exceptions. Option number one is the automatic generation. So the Java itself generates the exception and throws, and that happens whenever you are going to violate the rules of the Java language or the constraints of the Java execution environment. Second possibility is that you can manually generate your exceptions and throw them. So that will be required whenever, for example, you want to report some particular situation to the caller of a method.
So Java actually provides a set of 5 keywords which can be used for handling the exceptions. Those 5 keywords are important, and we should know how and when to use which keyword for which situation.
So try keyword is used whenever you want to enclose the vulnerable instructions where you expect that the exception can occur. So you enclose the instructions in a code block and you call that block as a try block. Immediately after the try block, the catch block occurs, and inside the catch block you provide the exception handling code where you actually want to write the instructions which will be executed in response whenever an exception is occurred. The throw keyword is actually used to manually throw an exception, which we will be throwing later on, and we can throw an exception manually if we want to report an error to the caller of a method. The throws keyword, which looks like similar to the throw but is different in actual application, is used to declare that a particular function can throw such type of exceptions. And the finally keyword is used to write the code to create such a block of code which you want to execute in every possible scenario, whether the exception occurs or exception does not occur. So guys, this format here explains the typical arrangement of those keywords and usage of those keywords, which generally represents that try will be a code block followed by a multiple or a single catch block. So there could be a number of catch blocks where every catch block will actually be responsible for handling a different type of exception. And then lastly, the finally block is placed, and this finally block is used to write such code which we want to execute in any scenario, either the exception occurs or it does not occur.
Now, interestingly, we should know what happens when we do not handle the exceptions. That leads to the scenario where we are leaving uncaught exceptions in our program. Yes, the answer is very obvious. The program is going to crash. But the point here is that how the program crashes.
For example, in this given code scenario, we are declaring a variable t and assigning a value 0, and I'm trying to divide this number 42 with a 0. In this case, this program should not be successfully executed, rather it should crash as a result of division by 0. And this is exactly what happens. When the Java runtime system detects an attempt to divide by 0, it constructs a new exception object and then throws this exception. And instead of seeing a regular output, we would be seeing an exception with the stack trace and the exception message in the console screen. So it says exception in thread main java.lang.arithmetic exception division by 0 at exe0, which is the name of the class, dot main, which is the name of the function which actually caused the exception. And then we are actually providing the line number and the file name, which is exe0.java at line number 4. So this shows that we are printing a complete stack trace from where the exception actually originated and the type of the exception which the Java runtime system automatically detects. So it says this time the arithmetic exception has actually occurred. So the throwing of an exception actually causes the program execution to stop. And to avoid stopping your program execution, the exception handler must catch the exception. And if we do not provide any of our own exception handlers, the default handler actually takes action, and that default handler is provided by the Java runtime system. It performs 3 different responsibilities. It displays a string which describes the exception. It prints the stack trace, which actually tells from where the exception actually originated. And finally, it terminates the program. So as I have discussed earlier, this is an example of a stack trace which actually explains the sequence of method invocation that led up to the error. And once again, this arithmetic exception is one of the built-in exception types in Java. So Java automatically detects that this situation or scenario matches the arithmetic exception scenario, and it generates that appropriate exception by providing all the required information. So in this example now, you can notice that the value and the message in the stack trace has actually changed. just because the exception that has actually originated is not in the main function, rather it is in a function that we are calling from within the main function. So you can notice that it mentions the address or location of the subroutine 1, and then it tells that this has actually been called from the main function at line number 7. So the bottom of the stack is the mains line 7, which is the call to subroutine, which caused the exception at line number 4.
So as exception is an object in Java, it creates the object of an appropriate type of the exception which matches the current scenario. And then that object is thrown from where the method was actually called.
Errors are represented by exceptions. Well, each exception is actually an object, so each exception type is described with a class. Now, as with all classes, the root of the class hierarchy for exceptions is the object class. When an exception occurs, it is thrown, and of course, we use something to handle it. Well, in order for a class to be able to be thrown, it has to inherit from the base class throwable. Now, one of the classes that inherits from throwable is the class error, and of course there are a number of classes that in turn inherit from the error class. But any error that occurs that inherits from this class error is generally one we do not care about too much, because these are some kind of problems which we are not associated directly. So there are some issues in the runtime environment. An example of one of these might be a linkage error. A linkage error occurs, for example, when you try to load a class and it's not able to load that class for some reason. Now, the errors that we tend to interact more are actually inherited from the class exception. And there is another class called runtime exception that is further inherited from the exception class, and there are many other classes which are inherited from the runtime exception. Generally speaking, those classes that inherit from the runtime exception represent errors in your program. Not always, but very commonly. An example of those might be a null pointer exception. So you're actually trying to use a reference variable that you have never assigned to. So that's a kind of a programming error actually. So we will see that there are times that you want to handle those certain runtime exceptions. And one of the other group is the subclasses of the exception class, which inherit directly from the exception class. An example here might be when you are trying to interact with a file and you are not able to interact with that file. So the type of the class that we use in that scenario is the IO exception class, which is directly the subclass of exception class. And all the classes that are subclasses of the exception class are actually called the checked exceptions. The checked exceptions are actually those which compiler looks into directly and try to make sure that you handle those exceptions. You add the exception handling code if any of those type of exceptions are occurring in your code. The other type of exceptions is the unchecked exceptions. So the occurrence of unchecked exceptions will not be checked by the compiler, and of course they will come into life or they will occur into your program once the buggy code is executed. That means they will occur or they will be identified only at the runtime. So one of the biggest difference between checked and unchecked exceptions is that checked exceptions are forced by compiler and used to indicate exceptional conditions that are out of the control of the program. That could be, for example, an IO error, that IO device is not responding. While unchecked exceptions are occurred during runtime and they are used to indicate programming errors. For example, a null pointer exception, an arithmetic exception, it could be a number format exception, it could be the exception like division by 0. So because these are those scenarios which can occur only at the runtime, the compiler cannot predict them. They may or may not occur. But the checked exceptions are for sure that compiler knows that they are there in the code, and if you have not handled, it will keep on complaining.